Hello everyone. So let's do the question number 22 here. The question states that a block of mass m is placed on a smooth inclined wedge. Smooth means the nu is equal to 0 of inclination theta, right? As shown in the figure, the wedge is given an acceleration towards the right. That is given here a. The relation between a and for the block remains stationary on the wedge is. Here is the solution. We break up each and every possible force into its components, right? If this is a wedge, this is angle theta. Taking the center of mass as original origin point, we know the normal is always perpendicular to the surface of point of contact, right? The surface is this, the normal would be like this. Now, what we do is, we know that MA was applied in the direction this, right? So when we break it up, this angle would be theta, the corresponding angle property of two parallel lines. This angle would be theta. This is because this is theta, right? So breaking it up would be MA cos theta and MA sin theta, as it said here. Now, what we need to do is, we know the mg force, that is the gravitational force, is always towards the earth, that is towards the ground, irrespective of the point of contact of the inclination of the wedge. Hence, though wedge is like inclined, mg would be perpendicularly down. So breaking this up into its components is mg cos theta and mg sin theta, right? Now we can see we need to find that ma cos theta equal to mg sin theta from here, right? We had to find the relation between a and g if we use these two equations as done here. M gets cancelled out, right? We take cos theta on the other side. Now we can say that a is equal to g tan theta. Clear?